Great, thanks for joining us, guys, on a beautiful Wednesday morning. As was mentioned, my name is Rex Hansen. I'm joined by Rich Zwaap. We're here to talk about building cross-platform mapping apps and solutions using the ArcGIS Runtime. Before we dive in, I want to talk a little bit about who we are, so you know who you're listening to, actually, in this session. My name is Rex Hansen. I'm a product manager for the ArcGIS Runtime. I've been at Esri for nearly 19 years, been in the GIS field, Geographic Information Systems field, for over 20 years. I've been working with a lot of the software, whether it's both on the web and the services on the back end, database. Oh, there we go. I think I'm engaged now. You can hear me. Worked with a variety of products within Esri software suite and outside. I'm joined by Rich Zwaap, who's a dev lead for the ArcGIS Runtime with the Xamarin, focus on our Xamarin SDK. Rich has been a .NET developer for over 10 years, I believe, and worked within the GIS field for many more, actually, at this stage. So we both work for Esri, ESRI. Esri is the global leader in professional GIS, Geographic Information Systems, software, services, and solutions. We're headquartered in Redlands, California, which is tucked nicely between Los Angeles and Palm Springs. We were founded in 1969, so almost 50 years old. So a good question is, great, we work for Esri. What does Esri do? What does Esri help customers do? So this slide is designed to give you an idea of generally what we do with our software, services, and solutions. We're designed, or we enable our customers or help our customers create and manage solutions, be able to create authoritative 2D and 3D data, geographic data, and integrate that within existing systems. They can also manage heterogeneous, large spatial data types within those systems as well. They can extract value from that geographic data, and they can utilize that in different visualization and analysis capabilities that we offer as part of our software suite and service suite that enable our customers to understand different events and capabilities associated with their authoritative data. Being able to visualize that spatial phenomenon and location-based resources and establish associations, analyze impact, determine data flows, and better understand patterns within their data. But not just that, we want to be able to communicate. So we help our customers communicate these changes, these data workflows, this experience by sharing and collaborating with different capabilities that we offer as part of our product suite so that you can evaluate results. You can communicate or you can work with others with your geographic data. You can solve different problems and you can share those solutions, right? So that's a very general view of what Esri does to be able to help their customers. Now, where do these customers exist? They exist across many different industries, right? So think about this. Think about your business, the company you work for, the clients you might work with, and what type of spatial needs or geographic needs do you or do they have? So a couple examples here in different industries that we support a variety of different customers. For example, for businesses, Wi-Fi coverage in a place of business, working with different mining resources in a work site, tax parcel distribution within a municipality, the location of friendlies and enemies on a battlefield for our defense industry, traffic flows for transportation networks, microwave distribution in an urban setting, and so on. Different applications, different fields, a variety of customers, both large and small, across many different industries. So how does Esri do this? We use something called the ArcGIS Platform. The ArcGIS Platform has a set of common capabilities and patterns that are integrated into simple, complex patterns and workflows. So whether you're taking some of these capabilities, such as blending geodesign with spatial analysis and imagery for planning and analysis workflows, or maybe leveraging real-time information with computer-assisted dispatch for operational awareness, or maybe even using some of the pre-built apps in community engagement efforts to collect data in the field, or even storing asset information in large, high-performance back-end databases, all incorporating data across different management systems, different content such as base maps, either provided by Esri or authoritative data that you've created yourself or by your partners or others in the field. But most importantly, being able to visualize with mapping and 3D solutions across all platforms, across the entire platform. Now, these capabilities and workflows and patterns for working with those capabilities translate into products that are part of the ArcGIS platform. Great. So let's take a look at the system. So the platform as a system, we're integrating data in a variety of formats, maybe files on disk, maybe content within a database, services, operations, and capabilities. We're integrating those with different workflows and patterns and analysis capabilities that we have. And we're doing that at a variety of different levels within our software stack. So we have a set of server products that you can use for on-premise hosting of data, services, and analytics that are specific to your industry, to your needs. You can keep it private, you can make it public. It's up to you. We create a set of desktop products that are designed for creating and curating and analyzing some of your authoritative GIS data, your authoritative spatial data associated with the field that you're interested in. You can build out workflows, you can analyze your data, and you can analyze your data for patterns, and you can provide and publish that data and those services to make them available and share them with others either within your enterprise or within your system. We have an online solution which is designed for hosting data and services for you and analytics in the cloud, right? So this is something that's available for you to take advantage of. You can leverage it with your data. You can utilize some of the content that we provide in our online system as part of the ArcGIS platform. And we can share that, or you can share that within your organization or publicly, right? So a variety of different products that enable you to create and curate your data and host your data either on-premise or in the cloud. Utilize our system. Now, if we move off to the right-hand side of the diagram here, we're going to see a couple of different options with respect to, interesting, that's good, nice cheer, with respect to our client applications and SDKs. So we have a web offering that enables really cross-platform browser-based applications. We have a set of applications out of the box that enable you to create web apps. We also provide a set of APIs that enable you to. That's pretty good. I like this. They really enjoy our client discussion. Actually, this is great. This is great. Really, it's having an impact on other groups, which is great. Fantastic. Really excited. So we have a web offering for cross-platform solutions across different browsers, across different platforms, which is great. But this is a Xamarin conference, right? So we want to focus on native application development for devices. They knew native application development was coming up, right? So we're going to talk about Xamarin. They're excited. This is great. So what does that mean as part of the platform, right? So if we're targeting devices and capabilities that are available to clients that are targeting those devices, what do we offer? Well, for native application development, we offer the ArcGIS Runtime. It enables you to build native apps. And there's a set of capabilities that are common to the ArcGIS Runtime as a whole. Now, ArcGIS Runtime encompasses a variety of SDKs. We provide APIs that target a variety of different developer platforms. We have iOS for Objective-C, Android if you're a Java developer. We have a Java SDK to be able to build out Java solutions across multiple platforms as a cross-platform solution for, let's say, Linux and Windows. We provide a Qt SDK for C++, QML developers who want to be able to target any platform, Linux, Windows, iOS, and Android. We also provide a Runtime SDK for .NET that enables you to target Windows platforms as a .NET developer. And we'll be talking about the Runtime SDK for Xamarin here shortly. But these runtimes have a common goal. They have a common set of capabilities. One is, not only can you work connected with data that's available through services, but you can also work offline, right? So you can take your data offline, you can use it in the field, you can leverage visualization of your data, search, different analytical operations offline, right, with your data. These SDKs, as native application developer platforms, give you the ability to take advantage of the native user experience. If you want one app that looks the same across all devices, you can build it. If you want one app that looks immersive on different platforms and devices, you can build that too. So we give you the ability and the flexibility to give you that native user experience and that responsiveness that you expect within a native application. You can also access native APIs. You can leverage resources that are available on the device. We can accelerate rendering performance using onboard GPUs, right? We can leverage capabilities that are built into the device, such as GPS, gyro, or other sensors that you can integrate within your application easily, quickly, and it's responsive within a native application platform. Now, I talked a little bit about, obviously the title of this session talks about cross-platform solutions. I talked a little bit about our Runtime SDK our ArcGIS Runtime SDK for Java, for Windows and Linux. We also have a Runtime SDK for Android that enables you to target Android devices if you're a Java developer. Great. We also have a Runtime SDK for Qt, if you're a C++ or QML developer, to target almost any platform at this stage. But this is a Xamarin conference, so we want to talk a little bit about what we offer that's cross-platform for .NET developers. So how is the ArcGIS Runtime constructed? How is it built as a native application platform? All of our Runtime SDKs are built on a common core. This shares common logic that enables us to take advantage of local resources on devices across any platform. We're building out a common C++ core engine. This is built in C++. It's native. It's high performance. It's designed to take advantage of capabilities that are on the different devices and platforms. So that's a common core across all of our runtimes. On top of this, we're providing a common .NET API, a common .NET API experience, right? So generally in this tier, we're dealing with non-UI logic, right? These are business objects that are associated with your GIS or authoritative GIS data and analytics. This might be where you find something like a map or a set of layers, tables, different symbols and rendering mechanisms that you'd actually have for content within your map, working with or connecting to services or data or local data. Great, so we have a common .NET API, right? So as a .NET developer working in C#, you're able to work against this common API for non-UI logic. Now on top of this, we provide a UI layer, right? So when you're building a native application, in this case, there's a UI associated with it. And so we've got a set of UI components, controls, that are available for desktop or WPF, right? So if you're building WPF apps for Windows desktops, there's an API and there's a set of controls that are built on top of our common .NET API for the runtime. This might be where we see a map view as a control, right? And this is a visual control that then we can integrate with our business objects behind the scenes that are part of our common .NET tier. We also support a UWP, so Windows 10 Universal Apps. We support Windows UWP, and so we have a UI layer that supports the ability to display and render in that layer. And that's part of our Microsoft.NET experience right now. So again, we're talking about Xamarin, so let's take a look at what we offer with respect to Xamarin. Well, we've built out for traditional developers working with Xamarin, we built out a UI layer for Android and iOS, right? So if you want to take advantage of either Android or iOS, we have a UI layer built on top of one common .NET API surface at the same level as we have support for UWP and desktop WPF. And on top of that, we've actually built out a Forms UI layer. So if you want to take advantage of Xamarin Forms, it's still built on top of the native components, the native platform, the bindings associated with Android and iOS. You'll be able to take advantage of that. So what's in green here is really our Xamarin implementation, right? Built on top of the Xamarin platform to provide an SDK, an API for you guys to take advantage of the ArcGIS platform as Xamarin developers. Great. So we're interested in the ArcGIS Runtime SDK for Xamarin. So what was in green in the previous slide? What does that Runtime SDK offer? Now granted, as a .NET developer and building in C#, right, you've probably wanted to have for a while, and you've discovered Xamarin as a solution for being able to take advantage of your .NET development skills, your C# skills, the tooling that's available with C# and being able to leverage Visual Studio and the breadth and depth of that IDE, sort of second to none, basically, to any other development experience that we have. If you can take advantage of that and you can target iOS and Android, and maybe you can provide an abstraction layer on top that works for you, such as Xamarin Forms, fantastic. Those are the APIs that we support as part of our ArcGIS Runtime SDK for Xamarin product. As we saw on the previous slide, it's all built on one common .NET API surface. So if you decide to build an application that targets Windows, iOS, or Android, right, you're building on one common surface. That's a common language, common .NET language. There's different UI layers. There's different experiences there for the UI level within your application, but there's one common piece of logic built on top of our runtime core that you as .NET developers are able to take advantage of. And that's great, because if we can build on top of one common core, we can take advantage of common high-performance capabilities that are exposed within our core that enable you to do fantastic 2D and 3D mapping. So a set of other capabilities that are exposed within the API, such as being able to take advantage of online services and online content and integrate those services and content into your mapping solution, right? So it's not just what other people give you as a map. It's what you want to bring to the table as your data, as your map, as your content. You want to overlay that with other shared data. You want to overlay that with other open data sources. Fantastic. We can support anything that's online. We can support a variety of data sources that are local. You want to overlay that with maybe transient data that is designed to indicate or mark up content on a map. We have the ability to overlay graphics and information on top of the map easily, quickly. We have the ability to query and actually edit your data and then share that data, collaborate with others associated with your system so that you can share those changes with others easily and quickly. Working offline is critical. It's a critical piece of the runtime. Being able to use and save and collaborate with different mapping solutions and other data types and working with layers offline is critical. You may not be connected if you're working on mobile devices, and you need to be able to plan for that. Whether it's something you're able to, in a partially connected environment, be able to pull offline at will, or it's something that you provision before going in the field, we've got different workflows that support that. And it's not just taking your maps and data offline, it's also taking the ability to do different operations and analytics offline. So being able to search and route and do analytics actually offline is also a key capability of the ArcGIS Runtime. Obviously, as a native application platform, we can take advantage of device sensors, capabilities of the device, and we can integrate with that. And so those sensors can be integrated within your experience, within your application. Right, so all of this is part of the ArcGIS Runtime SDK for .NET and is shared with other runtime SDKs. Right, but we do give you basically we give you the components that you need to be able to build on top of a Xamarin platform and leverage some of your C# skills and some of the tooling that's available. We do support Visual Studio. We also support Xamarin Studio, right, as your IDE. So if you choose Xamarin Studio, you can use that as well. Great. So now that we have a nice overview of where the ArcGIS Runtime for Xamarin fits into our system to support devices, the obligatory add a map to your app slide, right? So let's show a little bit of code. Real small bit of code here just to show you how easy it is to actually add a map to your app. So in this case, 3 lines of code, right? We're going to create a map view control. If you recall from our multi-tier slide, the map view is a visual control. It's a UI control, right? In most cases, if you're building out an MVVM solution, this is going to be your view, right? So your map view is in your view. It's your visual control. Create a new map view. The second line, we're going to create a map, right? This is some non-UI logic that we want to be able to render within our map view control. So we have we can new up a map. We've got a constructor here that enables us to provide a couple of parameters here that makes it easy for us to create that map. In this case, we're specifying a base map type, and it's a topographic base map type. What is this associated with? It's associated with content as part of our ArcGIS platform. So we have content that's available for you to use, base maps in this case, for you to use freely within your application. And so we have an easy way of creating a map with a base map to provide context for your application. Also, we've got an override here so we can provide a location and maybe a level of detail. In this case, it happens to be Orlando, so if you can actually see the map on there, which is a little bit small, it's actually zooming into Orlando and at a specific level of detail. Right? So some convenience there at actually creating a map. Then I assign the map to the map view, and away I go. Right? So 3 lines of code, you get yourself a map, you get a base map, and you can go to a specific area of interest. Right? Nice and easy. But it kind of begs the question, well then, that's pretty easy. Well, why the ArcGIS Runtime for Xamarin, right? There's other mapping solutions that exist today. There's the iOS MapKit framework, right, for Apple devices. There's a Google Maps Android API that you could use and integrate with very easily, actually, on Android platforms. Xamarin Forms Maps leverages the vendor-specific mapping APIs that are available. There's built-in apps on different platforms. If you're working with iOS and Android, or even Windows platforms, there's different built-in capabilities and built-in apps that you can leverage through UI schemes. Right? That's great. So those mapping APIs provide some very basic. Obviously, they're providing mapping APIs because they're powerful tools for communicating to users maybe where they are, what's around them, and how they get to those places. Right? So some very common questions that happen within the general audience. They handle basically the who, what, and where. Basic navigation, set of base maps out of the box that are specific to vendors, integration with location, the ability to overlay graphics, shapes, annotation, and text, being able to call out information and show that on the map, right? Basic search and routing, Sometimes you see a little bit of pseudo 3D in there too, right? But those are basic mapping capabilities. The ArcGIS Runtime can do that, right? The ArcGIS Platform enables those capabilities as part of the ArcGIS Runtime. But if you want to go beyond the basic mapping capabilities, if you want to use the ArcGIS Runtime to go beyond, that's where we fit in. We basically allow you to take your data, whether it's private, it's part of your enterprise, you want to make it public, it's your choice, and you can make it your way, right? It can be in a spatial reference that makes sense for your specific data format. You can provide and you can host different data and analytics associated with your specific solution. Think about the industry that you're working in and the capabilities and the data formats that are necessary. Think about how that applies to your system, how that applies to your application, and being able to build your data and build it your way and make it consistently a consistent experience across all platforms is something the ArcGIS Runtime is best at. There's obviously some capabilities we've covered in the past. The ability to take advantage of utilization of offline data, right? And easily and package your map and your data and take that offline. Integrated analysis, whether it's online analysis through tools that we provide as part of the platform, or it's analysis capabilities such as, let's say, line of sight or viewshed that you might have available as part of the native implementation that you can use offline. 3D, another capability that's critical. Full support for 3D within our API and SDK across the platform, being able to utilize different analytical capabilities and data sources that are specific for 3D display. Obviously, many data formats, many open data formats. You want to use WMS, WMTS, WFS, right? You want to use OpenStreetMap, right? Different connected data sources and services are available to integrate within your solution, right? So really, it's your data, your way, and it's utilizing the ArcGIS Platform and the power of that platform to be able to take advantage of the capabilities that you need for your enterprise, that you need to be able to make available for your system, right? So that's the critical piece. We're going to take, the ArcGIS Runtime takes it beyond basic mapping. The other map toolkits are great, right? If you need to do basic mapping, that's fantastic. You can use them. We can do the same thing. But if you want to take it beyond that and you want to use your enterprise authoritative data and you want to use it your way, that's where the ArcGIS Runtime fits. Great, so enough chatter. Actually, we'd like to show a little code. So I'm going to pass this off to Rich, and he's going to walk us through a demo of a campus map and handling service requests. Rich?
All right. Thanks, Rex. So I am going to show a little bit of code, but not just yet. So right here, you can see we're in a browser. It's a little weird. Native developer conference, native app developer conference. What are we doing in a browser? Before we dove into some code, I wanted to just call attention to the fact that if you decide as a native app developer to use the ArcGIS Runtime, you're not only getting a powerful geographic API, GIS and mapping API, you're also plugging into a broad and powerful platform. So here, this is a map viewer in ArcGIS Online. I have a map open showing the Esri campus in Redlands. And here I've got a base map here that actually shows the entire world, and that is content provided by Esri as part of ArcGIS Online. And then on top of that, you can see I've got some custom data that shows the offices and other features on the Esri campus. And that custom data was, it's specific to our enterprise, to Esri. It was authored, created using ArcGIS software, presumably desktop software by a cartographer GIS analyst. And then this was published as a service out to the web. And then I was able to grab that service and bring it into the map we're seeing here. And this map, which we call a web map, defines a map configuration that can be used essentially across any device or platform. I can interact with it on desktops, obviously on the web, and then we can also consume that using the ArcGIS Runtime in native applications. So I'm going to use that, using this app, in a native app as a jumping off point for what we're going to build here. So here I am jumping into Visual Studio. You can see I have my Esri Campus app solution. I've got an Android app project there. Android is my platform of choice today. That's one of the things that's awesome about doing development using Xamarin. It's like you can wake up in the morning and be like, I'm in Orlando, I think today's an Android day, or I woke up on the left side of the bed, I think today's an iOS day. Or I'm feeling a little crazy, a little frisky, maybe I'll do wearables today. Or I guess I'm feeling nostalgic, maybe it's a Windows day.
Nice.
Sorry.
Tried and true.
Yeah. So today's an Android day. So then I've got my shared project here. Of course, that contains my view model, other business logic that I want to share across multiple platforms. First thing I want to take a look at is in that view model layer. Just a simple view model. I've got a few things subbed out, implementing iNotify property change to course, common properties like is busy, and status. Nothing really specific to the ArcGIS runtime as of yet, but let's fix that. So here I'm just going to bring in a map property, and as Rex already talked about, in the runtime SDK, this is a data object. So this essentially specifies my map configuration, right? So that belongs in my view model. Now I want to initialize that with the web map that we saw in the browser using the Esri campus. So I'm actually going to bring in a member variable that defines an ID. Now what's that? If we pop back out to the browser, you can see up here, there's an ID there. So every web map in the ArcGIS system has its own unique identifier. I'm popping that out into a member variable because I want to use it in a couple places as I build this out. And then we're initializing from a map that's out on the web, involves a web request that's asynchronous, so it can't be done in the constructor. So I'm just going to bring in a load async method that's going to do my map initialization there. And then bring in the implementation that actually, it does a little bit of state setting. You'll see that a lot in the code. That's just standard stuff. But then the initialization of the map is right here. And we're passing it a URI. Now what's this? So if we pop back out to the browser one more time. So this is a metadata page about that web map. This is another page on ArcGIS Online. And the URL here, if you can see that, matches the format of what I'm passing to here. And then I'm using a little string interpolation, thank you, C#6, to plug in my map ID member variable there. This is a secure web map, so I don't want to share with the entire world. I could share all this publicly, but I don't want to share with the entire world the specific data that's specific to my enterprise. So I'm just authenticating here using a convenient mechanism that's in the runtime SDK. So that's it as far as wiring up the map data. And I want to bring that through to the view. So let me jump over to my Android main layout here and bring in our map view object. So as Rex already touched on, that is the main UI element. That's the UI element we have for displaying a map. And then in my activity on create method, I've got some status initialization stuff. That's not anything specific to the runtime. It's just standard showing operation progress. But then bring in here things that are specific to our API. I'm actually listening to, the map view gives us a draw status event. I'm listening to that to do some status updates. Also, so I want to build this mobile app to help me get around the Esri campus, right? So as part of that, I want to be able to see where I am. So for that, we just have a convenient location display property, and I just have to start that to actually show, excuse me, where I am on the map. Now, of course, that's my map view. I need to initialize my map view model. Again, listening to property change for some status updates, calling the load method to do that initialization of the map, and then last but definitely not least, pushing my view model's map into my UI by setting the map view's map property. And let's give that a run there. So as you can see, I mean, it's pretty simple stuff to get up and running with this, right? I mean, so I already had that map shared through the ArcGIS platform as a web map. Basically, I just need to go get the URL for that, plug it in, and then if it's a secure web map, do some authentication, which is just easily done through a call to the API. All right, so it looks like that's starting up, hopefully. There we go. So you see we have the same map that we had in the browser now running on the mobile device, just like that. All right, so that's great. But this is a mobile app. One of the challenges of mobile apps is that connectivity is intermittent, right? I mean, I'm going around the Esri campus. I'm going in and out of buildings, so I might lose connectivity on my phone, or maybe I'm on a tablet that doesn't have cellular data capabilities. So one of the things the runtime and the ArcGIS platform allows us to do is to take web services, online data, and make local copies of that data. So here I've brought into my ViewModel a little method to do just that. And I have a one-liner call to the map to take it offline, essentially making an offline copy of it. So this is actually kind of a sneak peek into the future of the runtime and how we would do this. But today, there's a couple objects to actually grab individual data sets within the map and do this. I've just behind the scenes simplified that a little bit, but the API will look like that at some point in the not too distant future. And then I just have another extension method on the map to essentially serialize the map. There's a toJSON method on the map, and then also persist some metadata onto the device so that my application can detect when a map's actually been persisted. Now back to my initialization. So if I am in an offline state, I want my app to detect that, right? So to do that, I'm just going to try to open a map from disk, passing it the map ID property. It uses the ID and the path that it's saved to behind the scenes. And then if it finds it, just pushing that map into my map property. So that's all I need in my business logic layer. So bringing that into the UI. Now, I could be clever about how to take my map offline. I could detect whether there's connectivity, or maybe prompt the user, or maybe do a settings page or something. But I am an API dev. I'm not really much of a designer, so I'm just going to put a big fat button on there that says, hey, you can take me offline. So I've got that right there. Popping back into my activities on create method, just wire up the button and bring in my click handler, and then just saying to my ViewModel, hey, could you please take me offline now? And then deploy that out. And this calls attention to the fact that I could really use Xamarin workbooks in this demo, so I wouldn't have to go through the deployment cycle. Anytime, if you guys have done much Xamarin or Android development, every time you touch a layout and deploy, it's time to go get a cup of coffee. All right, so there we go. So it tells me my map's loaded from online data. I get my big fat take the map offline button, click that. And all that's downloaded, says it's ready for offline use. I want to prove it. So airplane mode, living dangerously. I have faith in my software. And you can see it just works. But wait, there's more. So I've saved that to disk, right? So let me restart that app, and it should, instead of going out to the web, it's just loaded it from its local copy of the data. Cool. All right, so what else? So I'm trying to build this app to help me get around the Esri campus. It's nice to be able to see where things are and where I am, but it would be a lot better if I could have some directions. So let's take a look at that. So let me pop back out to my ViewModel. Bring in a couple member variables. These are ArcGIS Runtime API objects. They basically define the style for data on the map. I'm just defining those to apply to the origin and destination points that are going to be in my route. I want to pull in some properties here. We'll dump them right here. The only one I want to call attention to here is this graphics overlay collection. In the API, we have this concept of graphics overlays, which are essentially overlays on top of the map. So a lot of map data, you want it to be persisted as part of the map. Some things are more transient, like routes, for instance. Occasionally, you might want to save one, but most of the time, you just want to throw it away when you're done with it. So that's what the graphics overlay is for. All right, a little bit of initialization code to initialize my routing and geocoding resources. These are, so I cheated just a little bit here. So this is going to be doing offline routing. I've already provisioned a device with the data sets that need to be there, just in the interest of time for this demo. Also here, I'm initializing my overlays that I'm going to use to actually show the results of the route. And then here I have a bunch of routing geocoding methods. I'm going to go super quickly through this. Code, lots of code, and stuff, and things. So we have 3 basic methods. 2 for geocoding the origin or from location, and for geocoding the destination. So what's interesting here, these take text, and this text is going to be an office number. So one of the things ArcGIS, the platform, allows you to do, you have your own data set, essentially, to do location operations or geocodes against. So I can get a location back, coordinates, from, say, office numbers. And then this is also taking the extra step of adding that to my overlays so that point can be shown on the map. Then I have a calculate route, which does what the name implies. I pass it the from point and to point. The only thing I want to call attention to there is we're actually doing 2 different calculations. So another thing, the power of the platform, we have a whole ton of different ways you can parameterize your routing operations. So in this case, I have one helper method for getting a route without any preference of whether I'm walking inside or outside, and another one for generating a route trying to stay inside, so say if it's a rainy day. Okay, bringing that through to the UI layer. So I'm just going to bring in a bunch of XML for surfacing a UI to allow my user to specify the from and to location. Then another chunk of XML down here at the bottom for showing information about my route results, in this case, the amount of time for each. And then back in my activity, I'm hooking up to a couple events that I've exposed pertaining to when it has route data. And then I also want to initialize my graphics overlay since that contains my route results. Then I need to initialize the UI for specifying the from and to locations, listen to events for when the user selected items on that, and also initialize the items that are going to show in the autocomplete functionality, which you'll see in just a second. And then last but not least, actually bring in the implementations of all the event handlers I just wired up. This is all, I'm not dwelling on this because this is all very UI view layer specific stuff. It's not really specific to the runtime at this point. So that's why I'm just sort of quickly glossing over that. Thinking about deploying, killed the other app. That's good to see. There's one thing we can quickly call attention to here, actually. Oh, too late. So all right, so there you see we have our UI. If I start typing offices, we see I get suggestions. Choose one, it zooms to it. So the suggestion functionality is also a feature of the API. So for finding locations, you can essentially search for suggestions of what the user, autocomplete suggestions of what the user might be trying to locate. So you see we've gotten our route back, and there's two routes, one that stays outside, and then another one that cuts through a building. So that's the indoor preferred route. Okay, cool. So, and yes, that was all, I'm still in airplane mode, still all working offline. So that's pretty nice. That's a nice little app to just help me find my way around the Esri campus. So what else would we want? Well, so a lot of people, Esri's a big company, big campus. There's a lot of staff involved in things related to asset management, so like IT or facilities, and they have to respond to service requests. So let's build on this app and make it a little more specific to their use case. So here I've pulled up a different web map. I could have added this to the other one, and that would have pushed through to the update, but I don't want to take the time to do that. Time's tight here. And this one you can see already has service requests highlighted in red. It has another data set or layer added to the map. So that's a different web map ID. So let's update that in our view model. And then I want to be able to, instead of having to manually type in, I mean, the autocomplete's nice, but the app knows where I am, and there's those service request features. So I want to be able to tap on one of those and just route from where I am to that. So I'm going to bring in a little method that's going to help me do that. And all this is doing, it's getting the data set that contains those office features. I'm initializing a query parameters object, specifying that I want to query things at the location. So that location is actually being passed in to the method call. And then on the data set, or layer that has those offices, I'm just running a query. I'm only returning one, and this is just preferring the results that have a outstanding status request. So wiring this into the UI. So I said I wanted to do this when we tap on the map. So there is a tapped event in my map view. So I'm going to hook up to that, do a little event handler for that, and in here calling out to my view model, find office method, passing it to the map location I get through the arguments to that event. And then there's a bunch of code that just deals with initializing the pop-up, initializing the information that's going to be shown on the pop-up. And this is just getting the information out of that office record that's coming back from this call, and initializing a pop-up UI based on that. Not really specific to the ArcGIS API there. So let's give that a run. And error initializing map. So this is okay, actually. We're still in airplane mode, and I updated the map, the idea of the map that I want to have my app talk to. So it needs to go back out to the web. So let's go turn Wi-Fi back on here. Gestures with a mouse don't always work so nicely. So now that's loading from the online data source. See, it comes in. And now the offices, there's something like 4,000 different office features, and it's pulling down all the rows, all the row data for each of those. So it takes a few seconds to first get that from online. We should see it come in here in just a second or two. Yep, there they are. So then it says, okay, we're done. You can take me offline. Cool. So we're offline. I'll prove it. And then this one's way over here. I'm not sure how to get here, so I'm going to, actually that's not, and my cancel button's hidden. There we go. So route to that. So routing from my current location over to that location, that office that I tapped on the map. All offline again. All right, so that's cool. What else? What more could we want? Well, I already have in my app routing to the service request. I'm responding to it. It might be nice to be able to, once I've resolved it, just update that from within the app, right? So we essentially want to edit that row, right? So I'm just going to bring in a little method into my ViewModel again. This one called save edit. It takes that feature, which is essentially a row in the database, getting the data set that contains the offices and saying to the data set, hey, could you please be so nice as to save the changes on that row for me? Wire that up into our UI. In this case, a pop-up UI, so I have a different layout for that pop-up that you saw when I tapped on the map. So I'm putting a save button in there on the pop-up. And then last but not least, back in my activity, in my GeoView tapped code, I need to wire up that new button. And when that's clicked, just save the edit, right? So now when that happens, it's going to update the feature. We're currently operating offline, but we have a local copy of the data. So what does that mean? It means in the local copy of the data, that feature's been updated. But the service online doesn't know anything about that yet. So you'll see in a second here, this will work nicely for updating this. So I can click on one and say, no, this one's okay, save that, and it disappears. So that request has been resolved. The data's been updated locally. But the service doesn't yet know anything about that. So how do we reconcile that? That's a problem, right? So the runtime provides capabilities to synchronize local copies of databases with the backend service. So I'm going to bring in some ViewModel code to do this, and the objects I'm using from our runtime API are right here. So essentially, again, I'm getting the data set with the offices, getting the local database that contains the local copy of my data, and then using this, we call it geodatabase sync task, to actually do that synchronization operation to reconcile the local changes with the backend, the master data set, essentially. So once again, need to bring that through to the UI. So in my, I put this in my activity. This needs to be in my ViewModel. We'll get that fixed. And now, a little bit of UI code. So back in the pop-up again. After I save and edit, so when do I want to do this reconciliation? Well, I want to do it when I save and edit, which is right here. So here, I'm checking if the network's connected. If so, then do that synchronization. Also, if we go, I want to check to see when we go from an offline state to an online state. And also, I have a timer that's basically on every elapsed, it's going to check to see if there's updates. And this goes both ways. I can push local edits to the service. I can also pull down updates from the service, or both at the same time. And then here's just the event handlers there, calling sync in both of those. And so now we're offline, but I have local edits, right? So actually, before I actually push this, let me bring this up. So here I have the same data in the map viewer here, but this is the master copy of the data. So let me set up a refresh interval here so we can see that come in. So notice here on the master data set, there's this edit right down here, and that's not here on my local copy. So let's go back online, which should trigger a push. So it says it's uploading edits. Thinking about it. And there. Oh, no. Oh, upload complete. One more refresh. And there we go. And like I said, it goes the other way too. So I can edit here. Let's go right here. Change this to, oh, that one's already got a service request. How about over here? No, apparently I like clicking on the same ones. There we go. Requested. Come help, very specific. And now we should see that show up. Actually did that. All right, I'm going to give this one more try, and then I don't think my original edit actually saved back to the master data source. So there we go. So there's a new one right there. So if all is well, we should see that come in. All right, let's, when in doubt, reboot, right? Let's just restart that real quickly. So we should see we have that polling interval. So it should tell us that it's checking. It still thinks it has edits to upload. All right, I was tweaking on this right up before the session. I must have gotten something goofed up there. But you did at least see that it did push the original edits back to the master data set. So that's essentially it. That's what I'm going to show for today, at least. But hopefully that gives you an idea of just how much power there is in the API and the platform. And that's really just the tip of the iceberg. There's all sorts of other stuff that I didn't touch on. Yeah, that's
Great.
basically it. Thanks, Rex.
Awesome. All right. Whoop. Little pop there. Good stuff. Whoop. Am I on? There we go. Great. So a great example of some coding wizardry from Rich, actually, on that one. So just walking us through a great demonstration of really some of the issues that I talked about earlier in the session, which is being able to take some authoritative data, geographic data, in this case, it's part of the Esri enterprise, and being able to author, curate that data, publish it online so it's available to your organization, be able to take that or build that into an app, and Rich showed us being able to integrate that within an application that ran on iOS using our Runtime SDK for Xamarin, being able to pull that data offline, make changes, synchronize those changes, update those changes, and visualize those in other clients, right? Visualize those changes that occur within your authoritative data as part of the enterprise, right? So a great example of being able to leverage the platform and the power of the platform, as well as the capabilities of the ArcGIS Runtime, taking your data offline and making changes and updating those, right? So a great example of that. So great, we've seen some nice, we've heard some good stories and some great ideas and capabilities here as part of the platform. We've mentioned some of the capabilities of the runtime, and we've demonstrated that. How do you get it? How do you get started, right? So a nice quick 3-step process. Right now, we're in a technical preview. This is a pre-beta edition of our ArcGIS Runtime SDK for Xamarin. You can download and install this for free. There's a site here in the upper right-hand corner. If you go to this site, it's a one-stop shop for everything that deals with the ArcGIS Runtime SDK for Xamarin. It'll take you to our early adopter site, which enables you to log in for free, download, and work with the Runtime SDK for Xamarin in Visual Studio, Xamarin Studio, your choice, and start building for iOS, Android, and leveraging forms if you choose. You can start coding right away, right? So I know as developers, a lot of times you don't like to read the doc. You just want to start diving in and see what's there. That's great. We have guide doc, we have library reference, we have samples for you to take advantage of, right? Those are accessible at this site, right? So it'll take you off to our GitHub repo with samples. We have a forum available on our beta community or our early adopter site that you can ask questions. Our development team is active in that forum in answering those questions and getting back to you. So start coding right away. Then at that point, take a look at the platform. Once you've created an account on our developer site, you can take advantage of that developer account, free capabilities as part of that account. You can access content, base maps, services, analytics that are part of that account. You can upload your data. You've got data sitting in an Excel spreadsheet or CSV, and you want to be able to add geographic information, enrich that with information that's associated with its geographic location. Fantastic. We've got services that enable you to do that and put it in ArcGIS Online as part of the platform, be able to consume that. At that point, you can create your maps. Just like we created a map here, you can create a map. You can share those maps within your organization with who you'd like and how you'd like. Right, so that's part of the platform. It's part of having that account, having a developer account, free to create and free for you guys to explore what's part of the platform, as well as start working with the runtime today. Great, so we have a tech preview available for free today. What's the release plan? Nice and simple, let's lay it out. The tech preview is our first public release, actually, of our ArcGIS Runtime SDK for Xamarin. It's pre-beta, right? So this is work in progress. It's quite rich in what it can do. But we're still adding functionality along the way, right? And so we need to further, we need to make the product more robust. We need to add additional functionality and capabilities so we can match some of the power of the platform and exhibit that within the runtime. So we have a beta, a public beta, which we'll be updating as part of our early adopter site. So the same location applies for our public beta. You can go out in June and you can get access to our public beta. We'll have additional functionality. We'll have support for UWP with the Xamarin Forms. We'll have 3D capabilities, right, in addition to other functionality that gets added into the runtime in time for our June release. Our first commercial release that you can use in production apps is scheduled for later this year. So Q4, likely November of later this year, we'll have a production release. We'll have additional functionality there, other data sources that we're able to access and integrate within your applications, and other capabilities that are part of the platform that we integrate within the runtime. Same location, developers.arcgis.com/Xamarin. That'll take you to the same location where you can either go get our beta or you can get our commercial release. It's always going to be the same, right? That's the place to go to get our Xamarin SDK. Now, I did mention as part of the beta that we're going to include 3D. That's a pivotal or critical capability associated with our runtime SDKs. So actually we do have, because this is an active development process, I got a brief example here of some of our 3D capabilities. Now this is an iOS application. It's running on an iPad. This is a scene, not a map, but this is not a map view, but a scene view. And what the scene view does is it enables us to take geographic data and show it in 3 dimensions and interact with it. So we have built-in navigation in a map. We have built-in navigation with the scene. In this case, we have a base map, an imagery base map coming from ArcGIS Online. We also have some data that we've crafted with some of our vendors and built out buildings, 3D objects, and given them textures. And so we can see, and I can interact with this app, and as I zoom in and kind of pan around, you can see some of the buildings in downtown San Diego. This is a 3-dimensional experience, a 3D experience that'll be in the Runtime SDK for Xamarin in our June release, right? So you can take advantage of this 3D experience. You can leverage 2-dimensional data within your 3D experience. you can take three-dimensional data and you can take advantage of that within our scene view, within our 3D capabilities as part of our runtime. Right, so a great example of this, I had someone ask me yesterday if we had a killer app. It's pretty early in the development cycle, but being able to leverage and show full interactive 3D and working with 3D objects and capabilities within a runtime SDK, within a native application SDK, is pretty critical. So if you want to take advantage or take a look at this, get a closer look, maybe get your hands on this demo, come by our island. We're in a booth 205. We've got a pretty large booth out there where we can answer questions, show off some of these capabilities, and maybe take it a little bit further and talk about some of the solutions that you might be interested in. Great, so we're coming right to the end of our session, and so we're going to bounce out to, let me see if I get the right connection here. There we go. Great, and so we're going to open it up for questions. While we're asking questions, though, I'm going to just a brief reminder here, where to go. Actually, if you want to get started, this is the one-stop shop. So let's open up for a few brief questions, and then we'll break. Yes?
Will vector maps learn the data?
I'm sorry?
Will you have vector maps in the beta?
Great question. Will we have vector maps in the beta? At this point, we have
Vector maps are
we have
actually
vector maps
there
in the tech
now,
preview.
right?
Yeah.
On iOS.
Right. So we do have vector maps supported. I think part of the vector map story is the support within the platform. Right? So we host vector maps, vector-based maps, actually on ArcGIS Online today. You can integrate those in the tech preview. Being able to author your own vector-based maps is coming with our desktop release of our Pro product within June. Yes? Right, so what is the global coverage of our maps, our content? It really depends on the content that you're looking at. Like if you're looking at road networks, we tend to have some limited, we're working with other data vendors, such as here. And those data vendors provide different levels of detail, depending upon what type of data they're providing. If you're talking about imagery, we regularly update our imagery content so that we can have the latest, greatest imagery content for as many locations around the world. Generally, it varies depending upon the content type and the vendors that we're working with. But our ideal is to have as great a coverage as possible, right? So oftentimes, depending upon the data that you're looking at, there's a variable answer to that, depending upon the content that you're interested in. But we do provide updates, regular updates to whatever that content is, so that you know when something's been updated or an update is pending, right? So broad coverage as best as we possibly can. As the world leader in this, we like to integrate with a lot of vendors to make sure we have the latest, greatest data available, geographic data. So great question. There was one in the back over here, I think, early. Yes? Multi-point routing available offline. Yes, we do, actually. So we do have the ability, so inevitably our routing mechanism and our network data set capabilities will continue to be enhanced to do cost-effective, cost matrix analyses, the ability to do service area requests, and the ability to do different complex network operations. So right now we have simple routing algorithms, simple routing capabilities that allow for multiple points inputted in that route. But eventually we're going to see that enhanced over time and being able to take advantage of that natively or locally within the runtime. So we'll continue to enhance that. Right. Not yet, actually, not at this stage, right? Yep, exactly. It is planned, though, so, yep. Yes, question? I'm sorry?
Oh, grid transformations.
Grid transformations, yep. The grid transformations are not yet in the SDK. As part of the runtime core, what we'd like to do is integrate those within our runtime core platform and then be available to make those available within our runtimes, actually. So it's our intention to make a full set of transformations available, actually, within the runtime. Yep, exactly. It's in the plans. Yes?
Okay.
Right. So generally, there's two different workflows. There's a workflow that is a bit more dynamic, generally for smaller data sets, actually, where the device is connected. You're able to take your map and data offline. Granted, the amount of data dictates how long it might take. If you're working over If we're working over Wi-Fi, it might be a little faster.
Yeah.
Obviously, you're working over your cellular plan, it might be a little bit slower.
You can also,
but
as part of the operation for taking it offline, you can select an area of interest and limit it that way.
Right, so you do have ways of filtering actually your data. There's another workflow which is provisioning, right?
Yep.
So you have the ability to, in the back office, you can actually build out your map and data and provision or make that available as a single download or side loaded onto a device so that you don't have that dynamic experience where you have to download it on the device real time, actually. So two different workflows, provisioning workflow and sort of a real-time workflow. Right. Hope that helps. Cool, great, awesome. Thanks guys, thanks for attending. Hope you have a great rest of the conference.